Hello, everyone. My name is Vlad. I work as an architect for Cloud Foundry at SUSE, and I have with me Dan Sinkovicz, and together we're going to talk about how we deploy Cloud Foundry on top of Kubernetes, on top of a mainframe. So why would you want to do this? Well, Kubernetes is a platform that's great for orchestrating workloads. But Cloud Foundry is an amazing platform for developers. So we want to bring the simplicity of the Cloud Foundry developer experience, the CF push experience to Kubernetes clusters everywhere, because this is something that will allow developers to focus on their business, on their application logic, and less on infrastructure. And of course, the Z system, the S390X architecture, we know is very performant, it's tolerant, it has high security, so it's loved by enterprises everywhere. It's obvious to want to bring these two things together, and this is what we're trying to do here. And hopefully the outcome is a system where you can easily deploy applications to Z using Cloud Foundry without even knowing that you're actually deploying to a Z system.
So what have we actually built? We had to make Z-compatible versions for all of these Docker images. There are three categories: Docker images based on BOSH releases. BOSH is used to deploy software packed in releases. Images for Irene, which is the new Kubernetes scheduler for Cloud Foundry. A MySQL image from scratch because we couldn't find a S390X version compatible with our cloud controller. A bunch of packages and OS images build OpenSUSE build series. The OS images are used to build base Docker layers and applications stacks for Cloud Foundry. To build all the required Docker images to make kubectl deploy successfully on Z, we first had to have a build system and some tooling. We used Jenkins as a build server and created jobs for all the images we need. This consists of first using the script we made last year for the Cloud Foundry operator on Z, Open Mainframe Project. We can take any release, any BOSH release, test it, and change the packages accordingly to the errors we get. Once the errors are fixed and the package successfully builds on Z, we can use Fisal for Z, which we have built last year as well, to create a Docker image. Finally, if the image successfully builds, we push it on the Quirks Docker Hub profile, and that's it. To make sure the applications are working as expected, we deploy kubectl and start debugging. Our development workflow consists on running kubectl using Helm. After that, we use K9S, which is a tool used to debug Kubernetes, to dig deeper and find the errors for the crashing applications. Following, we fix the errors and build Docker images as described before using Jenkins. And finally, we update the installation settings if that's necessary. This can happen if we change image names or applications or for other reasons.
Thank you, Dan, for explaining what we're doing here. And I'd like to take a bit of time to take us through the difficult parts of porting Cloud Foundry on Z. One of them was the cloud controller, specifically the gRPC Ruby gem that we need to use there was particularly difficult to compile. Its native extensions were difficult to compile on Z. This is because gRPC is not supported on little Indian systems, and we actually found some contributions from from developers out there that try to make this work on little Indian architectures, and we managed to get it working. So the cloud controller works right now, and it seems to be stable. And then the next part was the Diego cell. The Diego cells are the kind of old way of scheduling applications on Cloud Foundry. We had to fix a bunch of issues with the stacks, so essentially the container layers that support applications. We had to fix some storage problems when deploying on Z. But in the end, we hit a blocker with running runC containers with the Diego cells. We're not exactly sure why this is happening right now, because runC is supported on Z. It might be that the version is not quite right, but we're actually trying to go to Irene. Irene is the new scheduler for Cloud Foundry. It deploys applications directly to Kubernetes, so you don't have to run containers in containers. And so this is where we're at right now. Unfortunately, we do have a few incompatibilities at the moment between the Irene images that we've managed to build versus the cloud controller that we have. As I explained earlier, we had to go with a particular version of cloud controller because of gRPC. So the correct version dependencies for the cloud controller that allowed us to deploy, to build gRPC, unfortunately make the cloud controller that we currently have incompatible with Irene. But we're working on it, and hopefully we'll get to a working Irene soon. So again, what's next? Fixing this integration problem with Irene and the cloud controller. Once we get that, we should be able to run apps. And then finally, we'll have to document and comment this project. Everything that Dan mentioned, we have to publish and make sure that it's repeatable by other teams out there. You can find our code on GitHub. You can start with the Cloud Foundry Incubator, the kubecf project. And if you want to talk to us, either myself or Dan, you can find us on Slack, on the Cloud Foundry, on the kubecf dev channel, on the Cloud Foundry Slack. Thank you, and a special thank you to the Open Mainframe Internship Project and the Linux Foundation for making this happen. And now, a Q&A.